Yes. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, right?
Yes, your voice is clear.
Okay. Fine. So in the yesterday demo session, right, I was just briefing you about what is big data. Okay. So big data, nothing but huge volumes of data, right? So we have what are databases or specialized databases. Databases like Oracle, MySQL, SQL Server, DB2, and specialized databases like Teradata, Netezza, Vertica. So either databases or specialized databases, they can handle data up to some extent. So, but the drawbacks with the databases, right? Yes. Limited storage in GBs or in TBs, no parallel processing. As volume increases, speed decreases, right? Okay. See that if you observe this, query to query as 10 records, 1 lakh records, 1 crore records. As volume is increasing, the speed, see, the first query executes faster as compared to the other queries, right? As volume increases, speed decreases. If complexity increases, speed decreases, right? As complexity increases, speed decreases. Okay. And databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? So we go for Hadoop, right? Hadoop providing two services, storage and processing. It's a kind of technology where it's used for both storage and processing. Any technology is meant for either for storage or processing, but Hadoop is meant for both storing and for processing. For storing, it doesn't use any databases, as despite of this drawback, still Hadoop doesn't go with databases. It uses a special kind of file system called as Hadoop distributed file system. And for processing, it used like MapReduce or Spark. Previously, MapReduce was used. Now, totally, we are going with Spark, right? And Hadoop is meant for batch processing, but not for online processing, not for day-to-day operations, not for a single transactions or two transactions, right? For batch processing, like millions and trillions of records, right? There are two types of applications I was saying: online applications and batch applications. So online applications, user interactive applications. User interactive applications. Here user gives the input. Online applications, user gives the input here. User interactive applications, we say, right? Like online movie ticketing, online bank transaction, right? Batch application means user non-interactive applications. Here user is nowhere required. Railway ticketing, PNR status, right? So which happens in the background. It's user input is nowhere required, right? What is your waiting state? 200 or 100 or 50 are confirmed, right? This everything happens in automated fashion, right? But user has nothing to do with this. Which has more load, online or batch? Batch, because online means you are making a single transaction, but batch means, for example, generating credit card bill statements, right? For millions of customers. Phone bill statement for millions of customers, not for a single customer, right? So here, huge burden, huge load on this batch applications. Hadoop doesn't follow client server architecture. It's not for request response architecture. It follows master slave architecture, single master and multiple slaves. Hadoop cluster, we say like a group of nodes, CPUs connected in a network. There are two types of nodes: master node or name node, slave node or data node, right? Master node or name node, or slave node or data node. So then Single master and multiple slaves. This is the master node. Yes. Multiple slaves. Master and slaves, right? Slave 1, slave 2, and slave 3. Okay. Single master, multiple slaves. So if your data file, right? Your data is subdivided into multiple blocks. Your data is going to be divided into multiple blocks. Subdivided into smaller parts. Your data is divided into smaller parts. Each part is stored across one slave. Each part is stored across a slave. Means your data is distributed. Your data is going to get distributed, and data is processed by multiple slaves parallelly. So in this way, if you have got multiple slaves, like think that you have got some 50 slaves. 50 slaves or 50 systems are running parallelly on the same data, right? Data divided into smaller parts. The parts are distributed and are processed by multiple slaves parallelly. So two advantages we can observe here, right? Distributed storage and parallel processing. Okay, that's what I was just briefing here. So Hadoop master node assigns tasks. So think that some 10 lakh records in this, 10 lakh records in this, 10 lakh records in this. This 10 lakh records, executing this 10 lakh records is T1 task. This 10 lakh records T2 task. This. So 3 tasks are executed by the 3 slaves parallelly. So master node responsibility assigning the task to the slave. And load balancing means equally all the slaves should be given the tasks. Fault tolerance means multiple tasks are executed by multiple slaves. Suddenly, if any slave goes down, then the task of it need to be assigned to any of the other slave, right? So what are this master node responsibility? Task assignment, load balancing, fault tolerance, health monitoring. Okay. Fault tolerance means in the absence, if any slave goes down, then the task of that slave will be assigned to any of the available slave. Before assigning tasks to the slaves, right? Every master node knows the status of each and every slave, the health of each and every slave, right? Yes. Slave node responsibility, actually your data is going to be stored within the slaves and data is processed by the slaves. Data stored within the slaves, data processed by the slaves, right? Yes. Hadoop advantages means unlimited data storage. Horizontally unlimited scalability means data is increasing enormously. For example, Hadoop follows master slave architecture, right? Master and slaves. Today, if you are running a business, a small business, right, with a less number of slaves, tomorrow your business has increased, your branches has increased, your data is increased, your customers is increased. Still, you cannot go with the same number of slaves, right? So horizontally, we will keep on increasing the slaves. Horizontally, unlimited number of slaves can be added. There is no limit on the number of slaves that Hadoop can have, right? Okay. Okay. Very high speed processing because of parallel processing. Hadoop can handle all varieties of data, structured data, unstructured data, semi-structured data, right? Hadoop is an open source, no licensing required. Why database like Oracle cannot support unlimited storage means Yes, there is a limit on the number of slaves. Oracle, it can go with 256. MySQL also like 256. DB2, SQL Server, they can go up to this extent. Beyond that, they cannot support, right? But specialized databases like Teradata, Netija, Vertica, they can go with 512 slaves, but currently they are going with 1024 slaves. Still, I cannot say they can store unlimited data. But for Hadoop, there is no limit on the number of slaves. Any number of slaves it can go, right? Horizontally unlimited scalability. Yahoo, when first time implemented Hadoop, it went with 4,000 CPUs or slaves for storing its data. Currently, it is going with 12,000 slaves for storing its data. Facebook, when first time implemented Hadoop, went with 8,000 slaves for storing its data. Currently, it is going with 42,000 slaves for storing it. Right? Currently, it is going with 42,000 slaves for storing its data. Okay. Yahoo, it has taken a table. Okay, to check the speed of various databases, right? Yahoo has taken a table of 100 TB consisting of 1024 columns. The task is sorting based on 16 columns. What is the time taken by the various databases to process this? Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata like 3.5 hours. Netija has just taken 3 hours, but Hadoop just it has taken 3.4 minutes, right? And latest version of Hadoop has just taken 1.2 minutes. So what are the Hadoop ecosystem components, right? Now today I'll be discussing Hadoop ecosystem components. Hadoop ecosystem components. So what are the things I'm going to discuss as part of the course? Right? So we have got some storage and processing components, right? Storing and processing data like the Hdfs. First is like Hdfs, Hadoop distributed file system, right? Hadoop distributed file system. It is meant for storage, right? Hadoop Hdfs. It's meant for storage. Second, MapReduce. MapReduce, right? It is a parallel execution model designed for parallel processing. It's meant for processing, but currently we are very less using this MapReduce component. We have got Apache Pig. This is also meant for processing. Here very less coding it is involved. Very less code we are going to see. Here we use a language called Pig Latin language. Pig Latin language, right? Apache Pig Latin, right? So it is a simple scripting language where we can write complex operations in a simple way, right? Using Apache Pig. 100 lines of Java code. It is approximately the same task we can do in Pig with not more than 5 lines. That is what the easiness of Pig. Once again, can anyone please confirm whether my voice is clear or not? Anyone?
Yes, your voice is very clear.
Okay. Now, next component like Apache Hive, right? It is a kind of, it is also meant for processing only. It is a kind of data warehouse kind of environment, DWH, data warehouse kind of environment within the Hadoop framework, it uses a language called HQL, Hive query language similar to SQL, right? Yes, Apache Hive. Next, we have got a component called Scoop. Scoop, SQL plus Hadoop, right? SQL plus Hadoop. The first two characters of it, and last three characters of it forms a scoop, right? It is for import or export operations. It is for import or export operations. Importing data from databases to Hadoop and exporting data from Hadoop to databases. Import or export. And no SQL databases, no SQL, right? No SQL database, right? This we use go for random access. Hadoop performs sequential access, but it is for no SQL is for random access. First one, random access. Schemaless behavior. Schemaless behavior. Random access. Schemaless behavior. Means in the case of SQL, we have got schema from first record to last record, same number of columns we need to maintain, right? But in the case of NoSQL, record to record, different number of fields can be maintained. My first record with 3 columns, second record with 5 columns, third record with 10 columns. Record to record, different number of fields can be maintained. So as part of our course, we'll be discussing one NoSQL database, HBase. HBase is one of the NoSQL database. So HBase is especially designed for Hadoop environment only. No, for not for other environments. But we have got many other NoSQL databases, right? Like MongoDB, Cassandra, React, Peanut, Neo4j. We have got many NoSQL. In that most famous NoSQL HBase, MongoDB, Cassandra. Okay, upper next I'll be discussing about streaming data and technologies. Streaming data and technologies, right? Yeah, streaming data and technologies like Flume and Kafka. So I can say like Flume, Kafka. For streaming and advanced streaming. What do you mean by streaming? Means data which keeps on generating, data which keeps on incrementing. Such data we call it as streaming data. So we use Flume or Kafka. And we have got a component called Yarn, yet another resource negotiator from Hadoop 2 versions. Previously in the Hadoop versions like 0 version, 1 version, there were some drawbacks. Everything got rectified from Hadoop 2 version, right? Yarn we call yet another resource negotiator, right? Yes. And Zookeeper, right? Yes. zookeeper, it controls and coordinates all the other Hadoop components, right? Controls and coordinates all Hadoop components. Next, Spark, right? Spark is also meant for processing. Spark, very high speed processing, right? In memory computation, we say, right? In memory computation. Okay, one second. In memory computation. In memory computation means data storage will happen within the memory. Data processing also happens in the memory, right? RAM level storage and RAM level processing both happens with. Okay. So these are the components we are going to discuss, right? Within the Spark, first implementation by using Scala language, right? Spark by using Scala language. First thing, Scala fundamentals, Scala programming, Scala functions, Scala collections, Scala expressions. All this Scala programming will be discussed first before I go with Spark. Later, like Spark core programming. Spark core programming. Next, like Spark SQL programming. Okay, Spark SQL, right? Later, like how to create jar files, how to submit the jobs. Everything will be discussed in brief, right? Yes, Scala, Spark Core, Spark SQL, Spark streaming, micro batching, right? This is the things we are going to discuss all these components in brief. More concentration on Spark, which are mostly used like Spark, Hive, Scoop, streaming technologies like Flumark, right? And NoSQL database and Hdfs. These are the mostly used Hdfs, Hive, Scoop, NoSQL database, Flume, Kafka, and yeah. Okay. How exactly data storage and processing is happening within Hadoop? How exactly data storage and processing? Okay, how exactly data storage and processing in Hadoop? Data is stored in the form of files, right? In the form of files. These files are subdivided into blocks. These blocks are distributed across the slaves. These blocks are distributed. In Hadoop, data is stored in the form of files. The files are subdivided into blocks. Blocks are distributed across the slaves. Default block size. Previously, default block size is like 64 MB previously. Means your file is divided into 64 MB blocks. Now currently, default block sizes, right? Default block is 64 MB. Currently default block size is 128 MB. Latest versions. Okay. Previously it was 64. Now it is 128 MB, right? Yes. Now if you talk about, just observe this diagram, right? Just observe this diagram. 1 second. How this data is going to be divided, how this data is distributed, how they are getting processed. Observe this diagram once, right? f1.txt. I have got a file f1.txt. Some banking data. Size of this file. 200 MB. 200 MB means into how many blocks? Into how many blocks it is divided? File size by default box size. Number of blocks equal to file size by default block size. File size 200 MB by default block size. Assume it is 64 MB, right? 64, 180, 192 MB, 8 MB. So here you will get how many blocks? 4 blocks. Block 1, block 2, block 3, block 4. B1 stored here, B2 stored here, B3 stored here. Sixty-four, 64. But here remaining data, everything is free, right? Here nearly 8 MB is 56 MB free here. Now, if I take f2.txt, right? f2.txt. f2.txt, if I take it is a telecom data, right? Size, assume the size 192 MB, right? Yes. Number of blocks. Now this time 192 MB means 192 divided by 64 means 60, 60, 60. 180 plus 12, 192 means exactly 3 blocks. B5, B6, B7. Here I have got a query, right? Here 56 MB is free in B4. Why B5 data is not stored in B4? Okay. Here are my queries. .56 MB free in B4. Why B5 data? .56 MB free in B4. Why B5 data is not stored in B4? Why B5 data is not stored in B4 means, for example, if I want to retrieve f1.txt. Retrieving f1.txt means b1 plus b2 plus b3 plus b4. B1 okay, 64, B2 64, B3 64, but B4, observe this B4, if B5 stored in B4, if B5 stored in B4 plus 8 plus 56 means 256 you will get, right? 64, 64, 192 plus 256. But here actual file size is 200 MB only, right? But 56 MB you are getting a thing that is telecom data, it's banking data. If I'm retrieving banking data, you are getting telecom data also, right? Actual file size is 200 MB, but we are getting 256 MB. Wrong computation, right? So every block should have its own blocks. In a single block, no two files data is stored, right? So here I'm writing the design principles of Hdfs blocks. Design principles. Design principles of Hdfs blocks. What are those? Yeah. Every file should have dedicated number of blocks. Every file should have in a single block. no two files data to be stored. All the blocks contains equal volume. All the blocks contains equal values except the last block. Except the last block, right? Only the last block cannot contain the same. Remaining all will have this. Okay. Design principles with respect to Hdfs blocks. How exactly data stored in process, right? Now observe. Observe here, f1.txt I have got. F1.txt is the size is like 192 MB. Assume it's 192 MB. Number of blocks 192 by 64. Three blocks, three blocks at exactly three blocks. How these three blocks going to stored across this cluster? Slave 1, slave 2, slave 3, and slave 4, right? Okay. Think that you got three blocks, three slaves you got. B1 here, B2 here, B3 here. Three blocks means B1, B2, B3, B1, B2, B3, B1 stored in S1, B2 in S2, B3 in S3. Think that 10 lakh records, 10 lakh records, 10 lakh records, 10 lakh, 10 lakh, 10 lakh. So here master node stores the metadata, that is f1.txt divided into three blocks, B1, B2, B3, where B1 stored in S1, B2, S2, B3 in S3. This is how the data storage happens, right? So the three blocks is stored across three slaves. Metadata is stored by the name node, and the actual data is stored within the data nodes. And how this data processing happens. So your job is to process f1.txt file. So job always defines, always the job divide will be divided into tasks, number of tasks, number of unique tasks, number of unique blocks. How many? Number of unique blocks. Number of unique tasks equal to number of unique blocks. How many blocks here? 3 blocks, right? Here 3 blocks. 3 blocks means how many tasks? T1, T2, T3. My job is to process f1.txt, right? Into how many tasks it is divided? T1, T2, T3. T1 task, T2 task, T3 task. T1 is for executing B1 block. T2 is for executing B2 block. T3 is executing B3. Who should execute this T1 task? Anyone? As B1 is present in slave 1, S1 only should execute, right? T2 task, who should execute? T2, this block B2 is present in S2 slave 2, so S2 only should execute. And B3 is present in S. So here. S1, S2, S3, right? S1, S2, S3. So for 3 slaves, S1, S2, S3, right? 3 slaves. S1, S2, S3. These 3 slaves are executed by, so these 3 slaves executing these 3 tasks parallelly, right? These 3 slaves are executing these 3 tasks parallelly. S1, S2, S3. Parallel processing. T1 task assigned to slave 1, T2 to S2, T3 to S3, right? So these 3 tasks executed by the 3 slaves parallelly. How this storage happening, how it is stored, and how the processing happening, and how the tasks are executed by the slaves, right? Okay. So in the tomorrow session, just I'll be discussing in a more precise manner. I'm going to say you 4 cases here. If number of slaves and number of blocks are same, how what happens? If more blocks, less slaves, what happens? I'm going to discuss 3 cases tomorrow, step by step, how the data storage and data processing is going to happen, right? Any query as part of today's session, anyone, right? So it is an offer batch, right? Where we are giving both the courses Hadoop and Spark combinedly. Okay, for just a fees of 10,000, only for 10K, that is Hadoop and Spark. So previously there were 2 separate courses, Hadoop and Spark. Okay, now combinedly we are providing, right? Yes. So I'll be taking nearly 90 hours, right? 90 hours to 100 hours for this. So nearly 50 hours I'll be spending on Spark and 40 hours on Hadoop. Totally 90 hours, like 2.5 to 3 months, 2.5 months I'll be taking, right? So in brief, you'll be getting knowledge on this entire Hadoop and Spark command. You'll be getting great command on this, right? Yeah. Any queries you have got, anyone, right? So as part of this course content is concerned, so you can just go through this course content, right? Hadoop Big Data, Hadoop, Hdfs, Scoop, SQL, Scoop, MapReduce, Yarn, Apache Pig, Hive components, SCALA, NoSQL HBase, SCALA collection, SCALA transformation, SCALA functions, Spark core, Spark RTD computations, persistence options, Spark core programming, Spark SQL, groupings, aggregations, deployments, submissions, all this stuff. Yes.
Uh, could you please share this PDF as well as you have written notepad, right?
Yeah, notepad I will be forwarding you, right? Yes. And if you see this course content, you can see in the chart panel, right? Our online team has already forwarded you this course content. If you can check this demo videos, you can see the chart panel, right? In the chart panel, 2 3 messages given by this online team: demo links and course content. Demo link, already the video, demo link video, and the course content is provided. And also the fee structure and fee payment, like the soft copy of material, videos, and that contact details of this online team for future reference. Yes.
Okay, these videos are downloadable or only?
No, it's not downloadable. You can only view them. Okay, fine. So understood, right? What we have discussed.
Yeah.
So here I was
Yeah,
just
this notepad I need, which you are showing this notepad.
yes, drawbacks with the databases, Hadoop services, online applications, batch applications, master and slave responsibility, Hadoop advantages, why databases cannot support unlimited storage. So storage point of view, processing point of view, Hadoop is proven in the market. Hadoop ecosystem components, how exactly data storage and processing, design principles, right? How exactly data stored and processed, right? Will we discuss it? Okay, fine.
Yeah, this notepad, where can I get this?
So actually these notes and okay, you can get the demo videos, but notes you'll be getting only once you are enrolled, right, with this course. Once you got enrolled or once you got okay, registered with this course, daily or every alternate days you'll be getting these notes. So clear notes will be provided, the soft copy and the software will be provided, videos on regular basis. Every day you'll be getting the videos. Okay, fine. It's all this. Okay.
Okay, thank you.
So I'm stopping here for today. Meet you tomorrow.